live from Soho, New York City. It's Wearable Electronics with Becky Stern.
Hi, everybody. I'm Becky Stern. This is Phil.
Hello.
Today we're going to talk about wearable electronics like we always do. What's on today's show?
On today's show, the code is MINI, but save Biggie. I don't know. MINI, 10% off everything in the Flora and Wearables category expires 11:59 p.m. Eastern Standard Time tonight.
Woot.
Wearable Wednesday.
We're going to talk about the coolest things in wearables this week and debut a new video project for you.
All the electronics that's fit to wear is like what I like to say.
Totally.
I change it up some weeks.
Yeah.
Except component of the week.
So we're going to talk about some wireless transmitters and receivers.
That's right. A new segment, tools we love.
These tools are going to really suck.
Yeah. Oh, that's funny. I know.
Hint.
Yeah.
Hint. Tune in to find out what we're talking about.
You got questions? Becky has answers. Your question answered live here on the show. All that and more on Wearable Electronics with Becky Stern. Oh, I have a graphic. Ding, ding, ding.
That's what that graphic's for.
That's what it was for.
All that and more on Wearable Electronics with Becky Stern.
All
is
that and
the
more.
Cool animation by the Ruiz brothers.
Yeah. So we got that going on.
If you have questions during the show about wearable electronics that you'd like to answer, the good questions, or the pertinent topical questions about wearable electronics, get asked on the show. I will answer them and also then enter you in a giveaway. Today's giveaway winner, it's in my pocket actually, is receiving one of our component of the week transmitter receiver pairs. And so you can ask questions on Twitter, on Google+, on the YouTube comments below, on the blog, on Facebook, and we'll enter you in the giveaway if we answer your question on the air.
Yeah, and it's getting close to holiday season, so that code MINI is a good thing to use if you want to get someone the gift of wearable electronics. And if you're waiting to the last minute, we also have gift certificates. And this is a picture of our gift certificate. Yeah, it's also helping us keep the camera focused. Focus, camera, focus.
This is really good multitasking. Like you just like gift certificates. It looks like a graphic, but it's actually the overhead camera.
Yeah. It's a still life.
Yeah, it's good.
All right, well, let's kick off the show. Wearable Wednesday is here. Becky.
There's a couple new products. That's why the code is MINI. So look at these mini NeoPixels. Look how tiny they are.
Yeah, these are cute.
They're just like tiny little circuit boards that you solder onto. I have a plan for a baseball hat, I think, with these. I don't know. They look really exciting to me. Or a tiara of all kinds.
Yeah, so you're going to put these on a hat? Okay.
I would like to.
And you're going to use probably a Gemma for that?
Gemma, yeah.
And then you can do all sorts of little projects and little sequences and all that. That's cool.
LED animations. These are just like super, super tiny, and you do have to solder to them. So they're like the smaller versions of the sewable pixels that we have. They're the same like hardware. They're just on a smaller board.
Yeah, and pictured here is the Trinket, and some big news. The Register. Like the Register is an interesting site. Like I've been around a while, so the Register was they're kind of cranky, but they're kind of good in that way. The #1 holiday pick for geeks, Trinket.
Wow.
Yeah,
fancy.
Geeky Christmas things. Yeah, they talked about Raspberry Pi was in the list, but Trinket, and they said it's under 8 pounds, as in the form of money, but it's like $7.
Which is also under 8 pounds.
Yeah, it is also under 8
American
pounds.
weight.
So yeah, the Trinket, and it's cool because the publication is known for being like snarky and everything. So when a snarky publication likes you, it means something even a little bit extra. Like you guys hate everything, but you like my thing.
Yeah.
So,
oh, gee.
Yeah. So that just happened just a few minutes ago.
Oh, yeah.
Yeah.
You can use Trinket to power all those tiny NeoPixels. And then the other mini thing today is these mini alligator clips. Oh my gosh. So you can go to the overhead. I brought some.
Okay.
Or overhead with our gift certificate graphic. So what these are great for is like you'll see in the GPS tutorial and all these tutorials before where you prototype your circuit with alligator clips. I was always tying my alligator clips in a knot because they were too long to go over to your like GPS or whatever. These are perfect length so that you can have all your parts like close together on the table and the wires are directly showing like what they're connected to. It's a lot easier to see what's going on without having to match up the colors. So you can just like attach your GPS or your other sensor over here. These are what I like to call shorties. Short alligator clips.
Yeah.
This was a request from Jessica from Parallax.
Oh right. Yeah, they actually Parallax has Flora now.
Oh really?
Yeah.
Oh.
Yeah.
Of course they do.
Yeah. And
Cheers,
it's neat. All the hardware companies were all starting to sell these stuff even more. Right before we hopped on the show, SparkFun should be carrying our NeoPixels. That's big news. So if you want to use those, and you have your shopping cart full of stuff over there,
which kind?
You'll be able to a variety of them. I think the rings. I think maybe the Shield. I can look later. But yeah, that just came in, so coming soon. There. Big news.
Awesome. So those are our new products. I'm going to cough. You might want to turn my mic off for just a second.
Cough.
Okay, thank you.
Back to
Tickle.
normal.
Yeah, you know, it's live internet TV. So that's why the code is
Yeah.
MINI, and you can use it to get 10% off your purchases in the Adafruit shop
Yep.
all day today. MINI.
Yeah.
For many things.
Speaking of mini and things that you wear,
Yeah.
this is all this show's about. What is this?
This is the Fitbit Force. So I got one.
Yeah.
Thanks, Phil.
Yeah.
And I've been wearing it around, and we like to tear things apart to see how they work inside. And Lady Ada is really good at not necessarily totally reverse engineering, but like the looking at the parts on the board and analyzing the design of the circuit, which is a
Yeah.
really cool part of the iFixit teardowns that
Yeah.
I always like the best. And so I invite Lady Ada over to my desk, and she drops some knowledge
Yeah.
on the circuit, and we find out how they cram all of those sensors into that tiny little space.
One of the things we like to do as a company is we like to learn from people that are doing cool stuff. Fitbit sells thousands of these. And so we like looking at the electronics. Moore's really good at identifying the components. And there's nobody doing video teardowns right now, especially very focused on wearables.
iFixit does really great teardowns, and we really
Yeah,
like their
yeah.
stuff. They're focused on repairability of really expensive gadgets that you only have one of, like your iPad or your laptop, and they also tear down phones, devices that are selling in the bajillions.
Yeah.
And they analyze how easy it is to put it back together. Nothing we ever tear down ever gets put back together because it's all stuff that's optimized for super small and not for serviceability at all, and they're usually not that expensive. So I think this guy's it's I don't know, $130 or something.
Yeah.
And the thing is glued together completely. So iFixit would never take it apart, since its repairability score would be -14.
Yeah. This was made not to be taken apart, and that's why we did it.
But that's this week's video, is the teardown that Lady Ada and I did of the Fitbit Force, and when we come back from the video, I'll tell you what I think about it.
Okay.
I'm wearing it every day.
That's perfect.
Welcome to another teardown at Adafruit. Today we're tackling the Fitbit Force. It's a wearable activity monitor that tracks how active you are, how many steps you climb, the quality of your sleep, that kind of thing, and then reports over Bluetooth to your computer to analyze your stats. Let's see how hard it is to take it apart. The Fitbit was a little bit deceiving. It had 4 Torx screws that were easily tackled with our screwdriver set, but once we took the screws out, nothing else would budge. I had to cut away the plastic to even get the band off at all, and then inside was more plastic and adhesive. I ended up soaking it off with acetone and then shaving away with my knife until I could finally find the circuit board. I'm in. Inside there's a tiny, tiny battery, an even tinier OLED display, a little vibrating motor it uses for its alarm clock, and the circuit board itself. Let's see what Lady Ada has to say about the design of the board.
Thanks, Becky. Let's check out what's in this Fitbit. Arr, arr, arr. The first part is this OLED here. So this is an OLED screen, and the reason that they use an OLED is, first off, if you want to have a small display, OLEDs are much smaller than TFTs. You can get much finer pixel resolution at a trade-off that it's only monochrome. We have OLEDs a lot like this in the store. Not as small as this one because there's not a lot of pixels, but we do have ones that are 128 by 64 or 128 by 32 pixels, and they're really high contrast. You can see them in sunlight or indoors, and they use very little power because there's no backlight. So that's probably why they use an OLED. This is a little motor in a case, and these are the same as the kind of buzzer motors that you find inside of cell phones, and you even see a very nice little M symbols. M is for motor. On the back, you've got a little mini battery. This is probably only maybe 50 milliamp hours at the most, maybe even less than that. You can see how OLED is connected. It's just soldered directly on, probably a hot bar machine, which it just sounds like a good place to go dancing, but it's not. It's actually a machine with a wire that they press the wire up against here, and it solders all the pads at the same time. And then you see here all these little TP points. These are test points, and that's really good because this way they can press it into a tester. There's little pogo pins that touch all these pads and tell you if the board is working, and if it isn't, what isn't working. So now if we can see all the circuitry, there's a lot of circuitry packed in here. It's almost all QFN, QFP, TSOPs, really small components. This is an NRF 8001. This is basically the front end for Bluetooth Low Energy. It kind of handles all of the radio and decoding part. It isn't a microcontroller, it's just sort of a front end section, but you can see that they have a nice big antenna. The NRF 8001 is connected over here to a microcontroller. This microcontroller is an STM which is a ST microcontroller, L151C6. So this is a low-cost 32-bit microcontroller. This chip over here, which you can barely see the part numbers on, is a TI, Texas Instruments BQ 24232 lithium-ion battery charger. Over here, we've got this little chip here. This is the accelerometer. It's a triple-axis accelerometer, and that's what's used to sense motion, how many steps you've taken, how fast you're moving. Unfortunately, the part got scratched a little bit. Either they scratched it or maybe in disassembly, not sure. So we couldn't identify it, but if I had to guess, it's probably a low-cost accelerometer from ST or maybe an LIS 3DH model, probably like a $1 triple-axis accelerometer. And then on the back here, there's a little bit of a victim of the teardown. To take it apart, we had to pull off this altimeter. This is a sensor that can detect barometric pressure, which will let you know how high up you are, because barometric pressure changes with altitude, as you learned in science class in 8th grade. So it's got a port on it, and it went over here. It's probably a very basic resistive or capacitive altimeter that is then sensed by the microcontroller. So there you go. You've got all these sensors, OLED, microcontroller, Bluetooth, antenna, battery charging, a whole bunch of stuff on the circuit board. A really nice design. Sad altimeter that got torn off. Nice Fitbit.
For this and many other teardowns, we use the Adafruit USB microscope with its articulated stand and the tiny Torx bit from this 38-piece screwdriver set. So I'm sure glad we don't have to try to put that Fitbit back together and that I still have one safely assembled on my wrist to wear around. But if you have an idea for a wearable you want to see torn down on another episode, post about it in the comments. And don't forget to subscribe to the Adafruit channel on YouTube for another Wearable Wednesday.
Okay, and we're back. Good teardown.
Thanks. Thanks, Lady Ada, too. But I'm surprised I didn't cut myself tearing that thing apart. When you try at home tearing down stuff, we do it so you don't have to, but be really careful with the knives.
Yeah, here's a couple photos. So you peeled it off.
Yeah, I peeled it off. It's glued like the whole way, and then when I finally I soaked it in acetone, I would soak it for a couple minutes until a layer would get soft, and I'd scrape it, and then I'd soak it again. And it finally broke through, and I actually broke through an antenna on my way in. You see how this antenna was fused with that plastic layer. Okay. That was sort of insulating the circuit board. So I don't know, it was fun, interesting to get into it. I've been, trying to keep tabs on all these commercial products while we build our own DIY wearables. And I had a Fitbit before, the kind that goes in your pocket, and it was great because it wasn't something I had to wear as a fashion statement every single day. Because it was in my pocket and hidden, I didn't have to think about it. But that meant that I also threw it in the laundry too many times. I killed 2 different Fitbits that way. So I was excited to try this one on because I knew I wouldn't accidentally wash it. But I got to tell you, I'm not a bracelet person. I type a lot, and so I don't love wearing it. I've been wearing it straight for the last 3 weeks now to try to see what I think about it. And for me, the really valuable thing is how many stairs do I climb, because I've got all these knee troubles, and I want to climb as few stairs as possible. Yeah. That information, for instance, helped my doctor analyze what apartment is good for me to live in because of the. I could tell him I was climbing however many flights of stairs a day. Yeah. Back when I had my other Fitbit, so it's cool. The OLED display is really bright and awesome. So it's also a watch, unlike the previous version of this same Fitbit. It has a full OLED display that doesn't just show you dots.
Maybe you can show it over there.
Other than that, you can show it on the overhead. Other than that, it's...
Okay, yeah.
Yeah, that's what I feel about this Fitbit. The OLED display is nice and bright contrast, super cool. The button's kind of on the wrong side for me, but you can wear it on either hand. And then the sleep quality thing, I think it's useful, but it makes me a little sad because it tells me that I was in bed for 9 hours and only got 6 hours of sleep. Yeah. So there's some information that, if I can't do anything about it, then why would I want to know it? Yeah. But it's cool. I think it's one of the nicest activity monitors that's out there now for ladies. When compared to something like the Nike Fuel Band, it's much more attractive. Comes in a couple different colors, and
that's cool.
And if you don't have an iPhone and you can't get the Shine, which will be our next activity monitor teardown.
I was reading that Disney has bracelets now. That you get a bracelet and it unlocks your hotel door, and all places in the park it's your ticket.
Sure, it's probably just RFID tag, right?
Yeah, but it's really neat. This idea that the bracelet's very futuristic.
Yeah.
All right.
We're living in the future.
Next up, we have a project that we were going to show. This came in the mail. This is from our team in Florida, Noah and Pedro Ruiz from Pixel 3D, And yeah, here it is. We'll go to the big one.
The overhead? You want to go with the overhead?
Well-
We'll just show the video. We have a video of this awesome this awesome Flora project wireless Bluefruit MIDI controller built with Flora and our arcade buttons and other buttons.
And 3D printed.
And 3D printed with Thingiverse files.
Yeah.
Let's just watch the video.
Yeah, let's watch the video.
Here's an open source, 3D printed MIDI controller powered by Bluefruit, Adafruit's wireless Bluetooth module. Playing music is always fun, but jamming out with your own custom-built instrument is even better. First, we'll need to remap the keys on the Bluefruit, using the step-by-step guide on Adafruit's learning system. Next, test out the buttons you want to use, and customize the enclosure design. The files are on Thingiverse. Print out the 4 parts in PLA. We're using neodymium magnets for the back panels. You can superglue them in for a secure fit. Next, assemble the 2 frames. Make sure to test the tolerances for your buttons and mount them into place. Test out all of the components using alligator clips. The Flora microcontroller will power the audio mic and 4 NeoPixels. Measure and solder the wires for all of the connections. Now you're ready to shred and jam out. Channel your inner rock star with the DIY open source MIDI guitar. It's a break away from the square buttons on a grid.
Alrighty. Okay, so that's it. Check it out.
Super cool. It doesn't make
Yeah.
any noise right now because it's not connected to the computer, but like these LEDs light up like the amplitude. These buttons are
Yeah.
illuminated, and these are super fun to play. And if you're lefty, you can just flip the files in 3D software before you print it out.
Oh, that's cool.
My favorite part is the way that these 3D printed panel has little magnets in
Yeah.
it, and it just like snaps on.
Bonk. Yeah, very clever design.
Yeah. So thanks, guys, for sending this to us.
Perfect
And
blend of 3D printing, wearable electronics, and NeoPixels.
Keytar
all together.
DIY.
Okay.
And the power switch.
Next up, component of the week.
This week I picked out our these wireless simple RF transmitter receiver pairs because they're really cool, and things like this have been around for a long time, but we found sort of the easiest ones to use and the ones with the most options for key fob remotes. They're kind of like garage door openers, and they
Yeah.
have 4. They're passive dumb modules. They don't have any microcontroller on them or anything, and they allow you to trigger 4 different buttons in a variety of ways. And we have a very short video that demonstrates the different momentary selector toggle type receivers.
Yeah, you use this on
The brake light backpack.
use it on a brake light backpack, and I've seen a lot of people use these in projects because it just works.
It's a good way to have wireless like mode changing. So if I made like an LED dress and I wanted to change while I'm out at the ball, I wanted to change the animation from like fire to ice or something.
Yeah.
This is a perfect solution because it's low range. I don't remember how many feet, but like
And low cost.
close distance. They're only a couple bucks. So I could put this on my keys and then like press A for fire mode and like change the animations without having to flip a physical switch, which could be kind of not convenient. So these are a perfect way to like have a wireless remote switch. And on the brake light backpack, it's so that you could have the remote up on the dashboard of your bike and then trigger the turn signals on the backpack.
Yeah, there's a million ways to do things. Like you could do XB, you could do Wi-Fi, you could do all this stuff.
XB is such overkill though for.
But this is the thing, and like this has a nice enclosure. So here is the video. Okay, and then
Overhead.
yeah.
Today's prize. So if you want momentary, like a lot of them, if you're working with a microcontroller, could be used for, like you could handle any one of the 3 types of receivers that we carry, and you could code it to work fine. But if you're triggering something that's not using a microcontroller, you might want the latching or selector type for whatever your project is. But like it's just got this little antenna, little circuit board, plugs in here, and this guy transmits, and they're all on the same frequency, so they all work together. That means that if you have multiple of them, they will conflict, and we have several different remote types too. This is the prize today for the giveaway, and it's the toggle type, the momentary type receiver and the 4-button transmitter.
Okay, before we move on to our new segment, the code is MINI, 10% off everything in the Adafruit store in the floor and wearable section. So here is tools we love.
New segment, what?
You're changing things. Change is scary. All right, so.
I promise this change is good. So
okay.
We're gonna do a new segment about tools. Oh, that sounds like it's not too far. It's not really that much different from what we're doing. We're gonna talk about a cool tool, because it's not a material, it's a tool. And today, these solder suckers. Man, these tools suck. I mean, they're the best suckers there are.
All right, so we got a couple photos of them.
Yep,
so we have 2 different types.
This is our basic solder sucker, and this is our extra fancy solder sucker. So for your getting into electronics repair, you could go with the lower cost, more basic one, and then we just got this fancy new one that's really been impressing me lately, and I wanted to show you why.
Yeah.
So on the overhead, you want to do the overhead?
Yep.
This is the extra fancy one, and it has this flexible silicone tip on it, which is really cool and useful for pressing right up against your the board that you want to desolder, so you can create a really good seal against it. And you can see here, often when I'm desoldering things, it's because I might want to reuse a floorboard in a different project, and the hole might be filled with solder like this one is, and the holes are quite big, so there's a lot of solder in there. And this guy, I would have to try a couple times, and it wouldn't always be successful to end up going back in with solder wick to try to get the solder out of the hole. And this guy with the silicone tip has really made super easy work of what used to be a complicated job for me, getting this hole cleared out so that I can sew to it again with conductive thread. So this has been a new favorite addition to my toolbox, the extra fancy solder sucker. And I want to do a side-by-side sound comparison for you.
Oh yeah.
This is the basic one. This is the fancy one.
Do it again, do it again.
Basic, fancy.
Okay.
Both at once.
If you have both at home, you could play a game where you can have a friend guess which one is which.
They have a pretty, the time they take to expand is the same.
Yeah.
You know, like they could be in an orchestra together.
Yeah.
You do a blind hearing test for you.
Yeah. Yeah, this one it has more like a rubbery stop in it.
Yeah.
And this one has more of a plasticky stop in it. Mm-hmm. Okay.
Anyway,
all right.
If you need to fix some electronics, remove solder that you made a mistake, or you're repurposing something else, pick up one of the solder suckers. They're also in, there's a solder sucker in Lady Ada's Ultimate Toolkit.
Yep, okay. Question and answers, you got questions, Becky has answers. We'll go through these and then we're gonna give away a prize. The first question is from Chase Johnson. I want to make a replica of Captain Jack Harkness Vortex Manipulator from Doctor Who, but I want the inside to be like the Neo Geo watch. Can you suggest a guide so I can learn about making a leather wristband?
Cool project, sounds really fun. I recommend, if you want to learn how to work with leather, we didn't actually make the leather wristbands for the Neo Geo watch. We bought them on Etsy, and there's a link to the seller in that guide. Okay. But if you want to learn how to make your own leather stuff or tool and dye and all that stuff, I would go to Instructables probably and start poking around over there for some crafty tutorials. I know that the internet is full of them. But we don't do that here.
And you know, speaking of costuming and everything, if you look on our blog, we have a new author on the site, Amy Ratcliffe, and she started posting today and yesterday. So check out her new stuff. We have a new section of costuming, cosplay. We hope to have more interesting projects for people too, and that'll show up on Wearable Wednesday, probably as a feature at some point.
Nice.
Yay. Okay, next up, how do wearable electronics survive washing with the wires and everything being rotted away?
Oh, gee.
Okay, gather around, everyone. I'm going to tell you the story of wearable electronics.
This is the most commonly asked
Grandpa,
question.
you've told that story so many times. I know.
You're going to sit through it again. Little Johnny hasn't heard it yet.
You're going to hear it again.
What was the commenter's name? Little so-and-so didn't hear the answer to this question yet. So
it's a popular question.
It's so popular.
We'll answer it every week.
Yeah, sure. I'd be happy to. No, I hate it when my electronics are eroded away. No, they don't. I mean, like electronics are made out of usually like plastic and metal, right? Circuit boards are made out of fiberglass, and then there's metal traces inside them. Components are made of metal and other materials and plastic. These things can get wet as long as there's no power going through them. So water, especially water in your washing machine, is conductive and will short out any power source you've got going on and could potentially damage components on your board and explode batteries. But if you remove the battery from most of the projects that you see on Wearable Wednesday or in our on the Adafruit learning system, most of them can get wet. So you just have to worry about agitation, like breaking things. So I would hand wash your projects. But if you're making something like the sparkle skirt, is like a precious garment that you wear out to a fancy occasion, like this dress I wouldn't put in the washing machine anyway, the skirt, you know? So like you think about like a t-shirt, for example, is not an optimal substrate for wearable electronics because it's stretchy and you always want to put it in the washing machine because it gets very stinky. So like, yes, you can wash these things. Once you make a piece of wearable electronics, it's a precious heirloom you want to keep forever, and you want to treat it with care, just like a valuable garment. So you would use, delicate garment care procedures like hand washing and hanging to dry. But then you just plug the battery back in, and you're all good.
Okay. Next up, dear Becky, hello. Would you help me figure out what's Arduino to use for the LED RGB waterproof 60 light per shoe? Should I use a Flora, Uno? What type of AC power? What should I use? Becky.
Dear Melissa, you're following the Firewalker LED sneakers tutorial. I think you should use a Flora.
Yeah, we designed.
Since you asked.
We designed the Flora specifically for projects like that, so that would be the best choice. And also, it's in the tutorial, and it works out great.
Yeah, and the battery, those shoes use. I wanted to make it super beginner friendly, and lithium polymer batteries can be a little bit dangerous for absolute beginners. So that's why we recommended the AAA battery pack for that project. But if you're a more advanced electronics user, you can certainly swap out one of our beefy lithium polymer batteries that are more slim and will fit in your shoe a little bit more easily. Yeah. So you can use either of those for that project.
Yeah, and from the blog, just real quick, this has been on television. This is the Firewalker. I played this on Ask an Engineer. And,
this is on Danish television.
Yeah, and you can check it out here. So look at that.
They look really good on stage, but those stage lights are competing with them a little bit.
Yeah.
But look at their reflection on the stage. It looks really awesome.
Looking good. Anyways, all right, moving right along. Hello, this is from Martin. In the Gemma NeoPixel earrings guide, you mentioned that a Trinket 5 volt is also okay. Are you able to run it with the LiPo you suggest in the guide, or do you have a power with a 5 volt power source?
Martin, you're putting words in my mouth. I went back and checked and was like, because I don't know that sounds like something I would say. And I went back and checked in that guide, and I don't mention anything about using the Trinket, and especially not the Trinket 5 volt. For the Gemma NeoPixel hoop earrings, you can use a Trinket 3 volt, but the 5 volt needs a 5 volt power supply like you suggested. So I don't know if you read that in the forum somewhere. Please send me a link so that I can put the record straight. But you should only use 3 volt Trinket or Gemma with the 3 volt batteries. And if you were, say, making like an animatronic, like a puppet that was wearing the earrings and you didn't want them to have their own battery source, you could use a 5 volt Trinket and run the wire like into whatever power source you're using to run the rest of your animatronic puppet robot that's wearing earrings. But if you want to go with battery power, I would just stick with the Trinket 3 volt or the Gemma.
Okay. And last question for Becky. What do you recommend is the best way to make a screen holder for glasses? I'm working on a wearable computer that browses web, plays MP3s, logs vital data, sends training GPS data, and uses a 2-inch TFT. All Adafruit products, which I got 10% off. Thank you. What's the best and only part I am missing? That's the only part I'm missing.
Cool,
Sorry.
Leo. That sounds like a really cool project. I can't wait to see it. I think that this is a prime candidate for 3D printing.
Yeah.
So you want to make an attachment for your glasses to hold the TFT. That's really cool. There's a guy here who is like a MakerBot person who made a thing called Glass Cap that's like a lens cap for your Google Glass. Kind of like that, right? An addition for your glasses that clips on and could hold the TFT. I think it's the perfect use of 3D printing. If you're not into 3D modeling yet, you could try Tinkercad or SketchUp. Yeah. And
and you can also, if you wanted to, but it's a little bit too permanent, Sugru. I mean, you could. Yeah.
It's just not it's not like a build-up material. Like you'd have to have a wire armature inside it, and I just think it's the perfect application for 3D printing.
Yeah, I think design it up and print it out. Okay.
You
Becky,
can send it out to Shapeways if you don't have access to it.
Before we give away something, how do people ask you questions on the show?
You can put them in the comments below, and I'll look through them for next week since we queue them up into the show. You can post them on our Google Plus event or page. You can send me or Adafruit a tweet. You can post it on our blog comments.
Lots of ways to get hold of
Shout
us.
it from the hilltops. Send
Yeah.
a carrier pigeon.
Yeah. Barn owls.
You could put the message inside a cake.
Yeah.
I like cake.
Yeah. Okay.
And
Pick the prize. Pick the winner.
then I print out your question and I put it in this bin that says things, and I pick one of them
All right.
at random to win the prize, which today is a transmitter receiver pair. Sarah, who commented on the blog, how do you wash wearables? You have won. Congratulations. If you'd be so kind as to send us an email at support@adafruit.com, you can claim your prize. I'll also hunt you down on the blog and try to get in touch with you. But you other guys, I know you have more questions. There's no restriction on how many questions you can ask.
You can ask forever.
Yeah.
Yeah.
So thank you for watching this week's
Yeah.
episode of Wearable Electronics with Becky Stern and Phil.
Yeah.
And we'll be back again next week.
Next week, more cool wearable stuff ahead. All right. Bye, everybody. Bye. Don't forget the code MINI, 10% off everything. Expires tonight at 11:59 p.m. And we are out of here.